you want a boiler operator job, you need a certificate. And to get that certificate, you must know these questions. Most people apply for boiler jobs without knowing either. In the next few minutes, I'll give you the complete roadmap, from getting your certificate to cracking the Viva board. Don't leave without watching this. It could land you your next job. Why should boiler operators understand combustion color? Answer: flame color provides important information about combustion quality inside the furnace. A bright and stable flame usually indicates proper combustion, while dark, smoke or unusual flame color may signal poor air-fuel ratio, incomplete combustion, or burner problems. Inspectors ask this question because experienced operators can identify combustion issues quickly by observing flame conditions. Incorrect combustion wastes fuel, increases soot formation, raises emissions, and may create dangerous furnace conditions. Operators should monitor flame appearance regularly and adjust burner settings carefully. Understanding combustion color helps improve efficiency, reduce pollution, protect equipment, and maintain safe boiler operation in industrial facilities and power plants. Why are boiler records and logbooks important? Answer: boiler logbooks provide a complete history of operating conditions, maintenance activities, inspections, alarms, and repairs. Accurate records help identify recurring problems, analyze efficiency trends, and support safe decision-making during operation. Inspectors ask this question because documentation is an important part of industrial safety compliance and professional boiler management. Logbooks also help during troubleshooting, audits, and accident investigations. Operators should regularly record pressure, temperature, water level, fuel consumption, and abnormal conditions carefully. Well-maintained records improve operational reliability, support preventive maintenance planning, and demonstrate that the boiler plant is being operated responsibly according to safety regulations and standards. Why is ash removal important in solid fuel boilers? Answer: ash removal is necessary because ash accumulation blocks airflow, reduces combustion efficiency, and increases furnace temperature imbalance. Excess ash may also damage grates, restrict fuel burning, and reduce steam production efficiency. Inspectors ask this question to test practical operation and maintenance. Knowledge in coal or biomass-fired boilers. Proper ash handling improves combustion quality, reduces clinker formation, and protects furnace components from overheating. Regular ash removal also improves workplace cleanliness and prevents unsafe operating conditions inside the boiler plant. Efficient ash management is an important part of maintaining reliable and economical operation in solid fuel industrial boiler systems. Why is boiler drum level difficult to control at high load? Answer: boiler drum level becomes difficult to control at high load because steam demand changes rapidly. When steam demand suddenly increases, bubbles form quickly inside the drum and temporarily raise the water level, known as the swell effect. When demand decreases, the water level may suddenly drop, called the shrink effect. Inspectors ask this question to test understanding of boiler dynamics and automatic control systems. Operators must carefully monitor drum level during load changes to avoid low water or carryover conditions. Proper feed water control systems and operator attention are essential for maintaining safe and stable boiler operation under varying industrial loads. Why is boiler maintenance important even when the boiler runs normally? Answer: boilers may appear to operate normally while hidden problems develop internally over time. Scale buildup, corrosion, leakage, worn components, and safety device failures can gradually reduce efficiency and increase accident risk. Preventive maintenance identifies these problems before they become serious failures. Inspectors ask this question to test long-term operational thinking and maintenance awareness. Regular inspection, cleaning, lubrication, calibration, and testing. Improve equipment reliability and reduce emergency breakdowns. Proper maintenance also extends boiler life, improves steam production efficiency, lowers fuel consumption, and ensures compliance with industrial safety regulations. A well-maintained boiler always operates more safely and efficiently than a neglected one. Why should boiler alarms never be ignored? Answer. Boiler alarms provide early warning signals about unsafe operating conditions such as low water level, high pressure, flame failure, high temperature, or equipment malfunction. Ignoring alarms can allow minor problems to develop into major accidents, equipment damage, or dangerous explosions. Inspectors ask this question because operator response during abnormal conditions is extremely important for plant safety. Operators should immediately investigate every alarm, instead of resetting it without checking the root cause. Proper alarm management improves operational safety, prevents costly downtime, protects workers, and ensures reliable boiler operation. A responsible operator treats every alarm as an important safety warning signal. Why is feed water temperature important in boilers? Feed water temperature affects boiler efficiency and equipment protection. Warm feed water requires less fuel to convert into steam compared to cold water. Higher feed water temperature also reduces thermal stress on boiler components because sudden temperature differences are minimized. Inspectors ask this question to evaluate understanding of heat recovery and energy efficiency concepts. Economizers and condensate recovery systems are commonly used to increase feed water temperature before entering the boiler. Maintaining proper feed water temperature improves combustion efficiency, reduces fuel costs, protects pressure, parts from stress damage, and increases the overall performance of industrial steam generation systems significantly. Why is boiler insulation necessary? Answer. Boiler insulation minimizes heat loss from hot surfaces such as steam pipes, drums, valves, and furnace walls. Without insulation, valuable heat escapes into the atmosphere, increasing fuel consumption and reducing system efficiency. Hot exposed surfaces may also create burn hazards for workers inside the boiler plant. Inspectors ask this question to test energy saving and safety awareness. Good insulation improves thermal efficiency, lowers operating costs, maintains stable steam temperature, and improves workplace safety. Operators should regularly inspect insulation for damage, moisture, or missing sections. Proper insulation is a simple but highly effective method for improving industrial boiler system performance and energy conservation. Why is proper boiler shutdown procedure important? Answer. Proper boiler shutdown prevents thermal shock, equipment damage, and unsafe operating conditions. If cooling occurs too quickly, metal parts contract unevenly and may crack or warp. Incorrect shutdown may also leave pressure trapped inside the system or create unsafe maintenance conditions. Inspectors ask this question because many accidents occur during startup and shutdown operations rather than normal running conditions. Operators should reduce load gradually, stop fuel supply safely, maintain proper water level, and allow controlled cooling before inspection or maintenance. Following correct shutdown procedures protects equipment, improves operational safety, reduces repair costs, and extends the overall life of the boiler. Why are boiler refractory materials important? Answer. Refractory materials protect the boiler furnace walls and reduce heat loss from high-temperature combustion gases. These heat-resistant materials help maintain furnace temperature, improve combustion efficiency, and protect metal structures from direct flame exposure. Damaged refractory increases fuel consumption, creates hotspots, and may overheat surrounding equipment. Inspectors ask this question to check understanding of boiler thermal protection systems. Operators should inspect refractory conditions regularly for cracks, erosion, or loose sections. Good refractory maintenance improves boiler efficiency, enhances safety, reduces operational costs, and extends the service life of furnace components operating under extreme industrial temperatures and combustion conditions. What is the purpose of a deaerator in a boiler system? Answer: a deaerator removes dissolved oxygen and other unwanted gases from boiler feed water before it enters the boiler. Feed water is heated inside the deaerator, causing dissolved gases to separate and escape safely. Removing oxygen is extremely important because oxygen causes corrosion inside boiler tubes, drums, and pipelines. Inspectors ask this question because many operators know the equipment name but not its real purpose. A properly functioning deaerator protects the boiler system from corrosion damage, improves water quality, reduces maintenance costs, and increases overall equipment reliability. It is one of the most important components in modern steam plants. Why is burner adjustment important in a boiler? Answer: proper burner adjustment ensures complete and efficient fuel combustion inside the furnace. Incorrect burner settings may create smoke, soot, flame instability, fuel wastage, and dangerous carbon monoxide formation. Poor combustion also increases emissions and reduces steam generation efficiency. Inspectors ask this question to evaluate practical combustion knowledge. Operators must monitor flame color, air-fuel ratio, furnace pressure, and exhaust gas condition regularly. A well-adjusted burner produces stable flame, lower fuel consumption, cleaner combustion, and safe boiler operation. Regular burner inspection and tuning are essential for maintaining maximum efficiency and minimizing environmental pollution in industrial boiler plants and power facilities. Why is oxygen dangerous inside boiler water? Answer: dissolved oxygen inside boiler water causes serious corrosion of boiler tubes, drums, and pipelines. Oxygen reacts chemically with metal surfaces and gradually creates rust, pitting, and thinning of pressure parts. Over time, corrosion weakens the boiler structure and may cause dangerous leakage or tube failure. Inspectors often ask this question because water chemistry is a critical part of boiler safety. Deaerators and chemical oxygen scavengers are commonly used to remove oxygen from feed water before it enters the boiler. Proper oxygen control extends equipment life, improves reliability, reduces maintenance costs, and prevents unexpected shutdowns in industrial steam systems. Why should boiler load increase gradually instead of suddenly? Answer: boiler load should increase gradually because sudden steam demand creates rapid pressure and temperature fluctuations inside the boiler. Quick load changes may disturb water circulation, reduce steam quality, and create thermal stress on boiler components. In extreme situations, sudden load increase can even cause priming or carryover problems. Inspectors ask this question to test operational discipline and understanding of boiler stability. A trained operator always raises load slowly while monitoring pressure, water level, combustion condition, and feed water supply. Controlled load variation improves efficiency, protects boiler parts, reduces operational stress, and ensures safe long-term industrial boiler performance. Why should steam traps be maintained properly? Answer: steam traps remove condensate and unwanted air from steam lines while preventing steam loss. If a steam trap fails open, valuable steam escapes continuously, wasting energy and increasing fuel costs. If it fails closed, condensate accumulates in pipelines and equipment, causing water hammer, corrosion, and poor heating performance. Inspectors ask this question to evaluate steam distribution system knowledge. Regular inspection and maintenance of steam traps improve energy efficiency, protect equipment, and ensure smooth steam flow throughout the plant. A properly maintained steam trap system reduces operational losses and improves the overall reliability of industrial steam systems significantly. Why are boiler safety interlocks important? Answer: boiler safety interlocks automatically stop unsafe operation when abnormal conditions occur. They monitor parameters such as low water level, high pressure, flame failure, fuel supply problems, and fan failure. If any unsafe condition appears, the interlock system shuts down the burner or boiler immediately to prevent accidents. Inspectors ask this question because safety interlocks are critical for modern boiler protection systems. Operators must never bypass or ignore interlock alarms. Properly functioning interlocks reduce human error, improve operational safety, protect equipment from severe damage, and help prevent dangerous boiler explosions. Regular testing of safety systems is essential for reliable plant operation. What is water hammer in steam pipelines? Answer: water hammer is a sudden pressure shock caused by fast-moving steam hitting accumulated water inside pipelines. This impact creates loud banging sounds and may damage valves, bends, supports, joints, and steam equipment. Water hammer commonly occurs due to poor drainage, faulty steam traps, improper piping, design, or sudden valve operation. Inspectors ask this question because it tests practical steam system knowledge and troubleshooting skills. Proper steam trap maintenance, correct pipe slope, effective drainage systems, and gradual valve operation help prevent water hammer. Ignoring water hammer problems may lead to serious pipeline failure, operational downtime, and expensive maintenance issues. Why is condensate recovery important in steam systems? Answer: condensate recovery improves energy efficiency by returning hot condensed water back to the boiler feed system. Since condensate already contains heat, less fuel is required to convert it back into steam. Recovering condensate also reduces water treatment costs because condensate is usually cleaner than fresh makeup. Water. Inspectors ask this question to test energy-saving knowledge and steam system understanding. A proper condensate recovery system improves boiler efficiency, conserves water, lowers operating expenses, and reduces thermal shock inside the boiler. Efficient industries always maximize condensate return to improve overall plant performance and reduce unnecessary energy losses in steam operations. Why is a boiler hydrostatic test performed? Answer: a hydrostatic test is performed to check the strength and leak tightness of the boiler shell, tubes, and pressure parts. During the test, the boiler is filled completely with water and pressure is increased above normal operating pressure using a pump. Water is used because it is nearly incompressible and safer than compressed air during testing. Inspectors ask this question to evaluate understanding of boiler inspection procedures and safety standards. Hydrostatic testing helps identify weak joints, cracks, leaks, and structural defects before operation. Regular testing ensures the boiler can safely withstand pressure during normal industrial service conditions without failure risks. Why is boiler ventilation important inside the boiler room? Answer: proper boiler room ventilation is essential for safe combustion and worker safety. Boilers require sufficient fresh air for complete fuel combustion. Poor ventilation can reduce oxygen supply, causing incomplete combustion, soot formation, smoke, and dangerous carbon monoxide accumulation. Excessive heat inside the boiler room may also affect equipment performance and create unsafe working conditions. Inspectors ask this question because ventilation directly affects safety and efficiency. A well-ventilated boiler room improves combustion quality, protects operators, prevents overheating of electrical equipment, and ensures compliance with industrial safety standards. Proper airflow management is a critical part of safe boiler plant operation and maintenance. What is boiler priming and why is it dangerous? Answer. Boiler priming occurs when water droplets carry over with steam due to high water level, sudden boiling, or excessive steam demand. Wet steam reduces steam quality and may damage steam turbines, valves, pipelines, and process equipment. Priming also creates water hammer conditions inside steam lines, which can seriously damage piping systems. Inspectors ask this question because it tests knowledge of steam quality and boiler operation. Proper water level control, good boiler design, correct steam demand management, and proper water treatment help prevent priming. Dry, high-quality steam is always necessary for efficient and safe industrial operation in steam systems. Why is excess air required for combustion in boilers? Answer. Excess air is required because perfect combustion is practically impossible with exact theoretical air supply. Additional air ensures complete burning of fuel and prevents formation of carbon monoxide, soot, and smoke. However, too much excess air is also harmful because it carries away heat through the chimney, reducing boiler efficiency. Inspectors ask this question to check understanding of combustion balance. Skilled operators maintain the correct air-fuel ratio for efficient and safe combustion. Proper burner tuning, oxygen monitoring, and regular combustion analysis help optimize fuel usage, reduce emissions, improve steam production, and ensure stable boiler operation under varying load conditions. Why is boiler efficiency reduced by soot formation? Answer. Soot is a black carbon deposit formed due to incomplete fuel combustion. When soot accumulates on boiler tubes, it acts as an insulating layer that blocks heat transfer from hot flue gases to water. As a result, more fuel is required to produce the same amount of steam, reducing boiler efficiency and increasing operating costs. Excessive soot also increases flue gas temperature and may create fire hazards inside the boiler. Inspectors ask this question to test combustion knowledge and maintenance awareness. Regular soot blowing, proper burner adjustment, and correct air-fuel ratio help maintain clean heat transfer surfaces and efficient boiler performance. Why should a boiler never be started too quickly? Answer. Starting a boiler too quickly creates sudden temperature changes inside the boiler shell and tubes. Rapid heating causes uneven metal expansion, known as thermal stress. This stress may crack tubes, damage refractory materials, weaken welded joints, and shorten boiler life. Inspectors ask this question because many operators focus only on production speed instead of equipment protection. A proper startup procedure allows gradual heating and pressure buildup, ensuring all components expand evenly. Slow startup improves safety, reduces maintenance costs, and prevents long-term structural damage. Professional operators always follow recommended warming procedures before bringing a boiler to full operating condition safely. What is the first priority during a boiler emergency? Answer. The first priority during a boiler emergency is protecting human life and preventing further danger. Operators must immediately follow emergency shutdown, stop fuel supply, and activate alarms if necessary. If there is a risk of explosion, fire, steam leakage, or toxic gas release, the area should be evacuated quickly. After ensuring personnel safety, operators should assess pressure, temperature, and water level conditions carefully. Inspectors ask this question to evaluate emergency response knowledge and safety awareness, quick decision-making, proper communication, and following standard operating procedures are essential to minimize injuries, equipment damage, downtime, and operational losses during emergencies. Why is steam pressure controlled carefully in boilers? Answer. Steam Steam pressure must be controlled carefully because both high and low pressure create operational problems. Excessive pressure increases stress on boiler components and raises the risk of leaks, equipment failure, or explosion. On the other hand, low pressure affects steam supply and reduces production efficiency. Pressure control systems maintain stable operation by regulating fuel supply and steam generation. Inspectors ask this question to test understanding of boiler balance and control systems. Proper pressure management improves efficiency, protects equipment, and ensures safe plant operation. Operators should continuously monitor pressure gauges and control systems during boiler operation for stable performance. What causes repeated boiler tube failure? Answer: repeated boiler tube failure is usually caused by poor water treatment, overheating, corrosion, scale formation, thermal stress, or improper operation. Scale deposits reduce heat transfer and increase tube metal temperature, eventually weakening the tube material. Corrosion attacks the tube surface and reduces wall thickness. Over time, sudden temperature changes also create thermal stress that damages the tubes. Inspectors ask this question to evaluate troubleshooting skills and maintenance knowledge. A good operator should identify the root cause instead of replacing tubes repeatedly without investigation. Proper water chemistry, regular inspection, controlled operation, and preventive maintenance are necessary to reduce tube failure problems. Why is furnace purging necessary before boiler startup? Answer: furnace purging is the process of removing unburned fuel gases from the furnace before ignition. Fresh air is circulated through the furnace using fans to clear any combustible mixture. If purging is skipped and ignition starts while fuel gas remains inside, a violent furnace explosion may occur. Inspectors ask this question because many boiler accidents happen due to improper startup procedures. Purging time depends on boiler design and safety standards. Proper purging ensures safe ignition, protects equipment, and prevents accidents. Every trained boiler operator must follow standard startup procedures carefully to maintain a safe working environment in the plant. Why should gauge glass be checked regularly? Answer: gauge glass is used to indicate the actual water level inside the boiler drum. If the gauge glass becomes blocked, dirty, or damaged, it may show an incorrect reading. False water level indication is extremely dangerous because operators may think the water level is normal when the boiler is actually dry. This can lead to overheating and tube failure. Boiler inspectors ask this question to test practical operational awareness. Operators should regularly blow through and clean the gauge glass to ensure accurate readings. Maintaining a clear and functional gauge glass is a simple but very important part of boiler safety management.